one of the biggest icebergs on record has broken away from Antarctica, creating extra hazards for passing ships as it now breaks apart.
To something scary that's unfolding miles away, which serves as a wake-up call for all of us.
A massive iceberg is free-floating tonight after breaking away from the ice shelf in Antarctica.
The satellite feed flickered to life on July 12, 2017. Scientists monitoring Antarctica's Larsen Sea ice shelf had been watching a crack grow for months, but nothing prepared them for what happened next.
And that crack has finally gone through all the way and formed an iceberg.
In a matter of hours, a wall of ice taller than the Empire State Building, a frozen fortress that had stood guard for over 120,000 years, simply ceased to exist. 1 trillion tons of ice. Gone.
More than 1 trillion tons and the size of Delaware, the iceberg is one of the largest to ever snap off.
Floating into the Southern Ocean like it never mattered at all. But here's what made researchers go pale. When they sent underwater robots to explore what had been hidden beneath that massive ice wall, the footage that came back didn't make sense. The instruments weren't malfunctioning. The data was real. What they discovered behind that collapsed wall wasn't just scientifically significant. It was impossible. A thriving world that had been sealed away since before human civilization, now exposed and changing by the hour. And this wasn't an isolated event. More walls are collapsing. More secrets are surfacing. Antarctica is opening up. And what's emerging from beneath the ice is forcing us to rewrite everything we thought we understood about our planet. The question isn't just what was behind that wall. It's what else is still hidden. And how much time do we have before it all comes crashing down? The guardian that failed. For millennia, the Larsen Sea ice shelf stood as Antarctica's silent protector.
Larsen Sea ice shelf is on the Antarctic Peninsula. It's about 2.5 times the size of Wales.
Imagine a frozen wall stretching across an area the size of Delaware, rising 1,100 feet above the water and extending even deeper below the surface. This wasn't just frozen water. It was a geological monument that had witnessed the rise and fall of countless civilizations without moving an inch. The ice shelf had formed during the last ice age, layer upon layer of compressed snow, creating a barrier so massive it seemed permanent, eternal, indestructible. Scientists called it stable. Climate models predicted it would take hundreds, maybe thousands of years to show significant melting. They were catastrophically wrong. In early 2017, satellite monitoring detected something alarming. Cracks were appearing in the ice, not the small fractures that naturally occur in glacial ice, but massive rifts stretching for miles, growing wider each day. The ice shelf was literally tearing itself apart from within, and there was nothing anyone could do to stop it. Research teams watched helplessly as the fissures expanded. They documented every centimeter, every hour, waiting for the inevitable collapse. It was not unexpected, one scientist admitted later. The crack had been monitored for at least half a year. It was more of a waiting game. But knowing it's coming doesn't prepare you for the scale of what actually happens. When the ice finally gave way, the sound registered on seismic monitors thousands of miles away. The force of 1 trillion tons of ice breaking free created shock waves that rippled through the ocean floor. The iceberg that broke away, designated a 68, was 4 times larger than London. To put that in perspective, if you placed it over New York City, it would cover all 5 boroughs with room to spare. The sheer mass defied comprehension. 1 trillion tons. That's more than the weight of every human being who has ever lived, combined and multiplied by thousands. And it was just floating away, drifting into the Southern Ocean, beginning a journey that would take it thousands of miles north before it finally melted away. But Larsen Sea wasn't alone. Further south, the Thwaites Glacier, which scientists had grimly nicknamed the Doomsday Glacier, was showing identical stress patterns. The same cracks, the same fractures, the same warning signs that had preceded the Larsen Sea collapse. And Thwaites is much, much bigger. As warm ocean water began flooding into the cavities left by the collapsed ice, research vessels rushed to the site. This was a once-in-a-lifetime opportunity. Whatever had been sealed beneath that ice wall for over 120,000 years was now accessible for the first time in human history. But there was a catch. The window was closing fast. Once warm water fully flooded these areas, the pristine environments would be transformed forever. What they found in those first exploratory missions made them realize they weren't just documenting a climate event. They were witnessing the unveiling of a hidden world that would challenge every assumption about Antarctica, about life itself, and about our planet's violent, unpredictable past. The race to explore these hidden depths had begun, and what emerged from beneath that collapsed ice wall was nothing like anyone expected. The impossible landscape. When the first sonar readings came back from the newly exposed seabed, the research team thought their equipment had failed. The data was showing underwater valleys plunging over 7,000 feet below sea level, deeper than the Grand Canyon. Technicians recalibrated the instruments, ran diagnostics, checked every connection. The readings were accurate. Antarctica had been hiding a landscape more dramatic than anything visible on the continent's frozen surface. What kind of geological forces could carve valleys that deep beneath solid ice? Ancient riverbeds snaked across the seafloor in perfect preservation, their channels still clearly defined after millions of years. These weren't small streams. They were massive river systems that had once carved through solid rock, with enough force to create waterways that could swallow entire cities. The last time water flowed through these channels, woolly mammoths still roamed the earth. The mapping data revealed mountain ranges buried under miles of ice, peaks that would rival the Alps, hidden beneath Antarctica's frozen surface, like something from a Jules Verne novel. Ridges, valleys, and plateaus created a topography more complex than Switzerland, all of it sealed away and unknown until that ice wall collapsed. But here's what really shocked researchers. The coastline they'd been mapping for decades didn't actually exist. The edge of Antarctica that appeared on every map, in every atlas, in every geography textbook, it was wrong. What we'd been calling the Antarctic coastline was just the edge of the ice sheet. The actual bedrock boundary of the continent sat hundreds of miles inland from where we'd drawn it. Antarctica was much smaller than we thought, its true size masked by ice that extended far into what we'd always assumed was ocean. Every map would need to be redrawn. As underwater cameras were deployed into the depths, they revealed something even more stunning. The seafloor wasn't covered in the smooth sediment that researchers expected from millions of years of accumulation. Instead, they found carved bedrock formations that looked sculpted. Smooth channels, polished stone surfaces, and carved basins showing clear evidence of massive water flow. These weren't the result of gradual geological processes. The evidence pointed to catastrophic flooding events that had reshaped the entire landscape in relatively short periods. Water had rushed through these valleys with enough force to carve solid rock, creating underwater canyons that made surface features look insignificant by comparison. The preservation was extraordinary. Without oxygen, bacteria, or weathering, everything remained exactly as it was the moment the ice first covered it. It was like discovering a snapshot of Earth's geological history, frozen in perfect detail for over 120,000 years. But the landscape itself revealed something that didn't match the climate models, something that made scientists deeply uncomfortable. The valleys, the river systems, the carved bedrock, all of it suggested that Antarctica had experienced periods of dramatic warming and cooling that happened far faster than current predictions allowed for. The geological record was showing rapid climate oscillations that would make our current concerns about global warming look gradual by comparison. How fast can our planet's climate actually change? The continent beneath the ice wasn't the simple landmass covered in frozen water that we'd imagined. Antarctica was revealing itself as a complex world of hidden mountains, ancient rivers, and landscapes that told the story of our planet's most dramatic climate shifts. And this was just the beginning, because as underwater robots pushed deeper into newly exposed caverns, they started detecting something that would challenge everything we thought we knew about the limits of life itself. Life in the eternal dark. The first robot to explore the caverns beneath the collapsed ice wall sent back footage that left the research team staring at their monitors in stunned silence. In the pitch-black depths, where no sunlight had penetrated for over 120,000 years, and where crushing pressure should have prevented any complex life, the cameras revealed something impossible. Life wasn't just surviving down there, it was thriving. Massive tube worms, some stretching over 6 feet long, swayed in the current like underwater trees. These weren't the small creatures you might find in shallow coastal waters. These were giants, their bodies translucent, revealing internal structures that pulsed with bioluminescent light in colors that shouldn't exist in nature. How can anything survive in complete darkness for over 100,000 years? The seafloor was carpeted with bacterial mats that glowed in brilliant alien colors. Electric blues, neon greens, deep purples, creating landscapes more visually stunning than any tropical coral reef. But these organisms weren't using sunlight for energy. They'd found a completely different way to live. These creatures had evolved in total isolation, cut off from Earth's surface biosphere for millennia. The DNA analysis that came back from the first specimens revealed something that contradicted our understanding of evolution. These organisms weren't just adapted to extreme conditions. They were genetically distinct from anything else on the planet. Some species showed genetic markers suggesting they'd been isolated far longer than the last ice age. We're talking about creatures that had evolved separately from the rest of life on Earth, developing in complete darkness for hundreds of thousands of years. Their genetic code told a story of adaptation that pushed the known limits of biology. The key to their survival was methane. Gas was seeping up from cracks in the bedrock, creating underwater oases where life clustered in impossible abundance. The methane provided fuel for bacteria, which formed the base of an entire ecosystem that had never been touched by solar energy. It was a parallel version of life on Earth, proof that biology could follow completely different rules than everything we'd studied on the surface. The bacterial communities were particularly stunning. They'd formed complex structures that looked like underwater cities, towering spires of living organisms creating their own microenvironments. Some areas showed evidence of symbiotic relationships between different species that had evolved together over millennia, each depending on the other in ways so intricate they resembled designed systems. And here's what made it even more remarkable. The methane seeps weren't random. They followed patterns along the ancient riverbeds, suggesting that the same geological features that once carried surface water were now channeling gases from deep within the Earth.
It's clear they must have symbiotic sulfur-oxidizing bacteria inside of their tissues.
The landscape was still active, still changing, even after being buried under miles of ice. The diversity was staggering. Every dive revealed new species, new adaptations, new ways that life had found to survive in conditions that would kill most organisms instantly. Creatures with no eyes but enhanced chemical sensors that could detect prey in total darkness. Organisms that could withstand pressure that would crush a human like a tin can. Life forms that generated their own light in a world of perpetual night. But perhaps the most significant discovery was this. These ecosystems weren't struggling. They weren't the last remnants of ancient life barely clinging to existence. They were thriving. The biomass in some areas exceeded what you'd find in productive surface ocean environments. This was a vibrant, complex, flourishing ecosystem that had been hidden beneath the ice, completely unknown to science. The implications hit researchers like a shockwave. If life could thrive in these conditions on Earth, in perpetual darkness, under crushing pressure, fed by chemical energy from the planet itself, what did that mean for the possibility of life elsewhere in the universe? Europa, Jupiter's ice-covered moon, has similar conditions. Enceladus, one of Saturn's moons, shows evidence of subsurface oceans beneath its frozen crust. Scientists had theorized that these environments might harbor life, but they'd never had proof that complex ecosystems could actually develop and thrive in such extreme conditions. Antarctica had just provided that proof.
Larsen sea ice shelf is on the Antarctic Peninsula. It's about 2.5 times the size of Wales.
But the living ecosystems were only part of the story. As researchers pushed deeper into the newly exposed caverns, they began finding fossilized evidence of Antarctica's past that was even more shocking than the life they'd discovered in the present. The forests that shouldn't exist. When researchers pulled up the first core samples from the newly exposed sediment, they found something that defied all logic. Fossilized tree trunks, perfectly preserved in the ice, massive temperate forest trees that belonged in North America or Europe, not at the bottom of the world. These weren't hardy shrubs or primitive plants that might survive in harsh conditions. The fossils showed oak, beech, and pine species, trees that required mild temperatures, regular rainfall, and actual seasons to survive. The preservation was so complete that scientists could still see the tree rings, count the seasons, and analyze growth patterns from millions of years ago. How could tropical forests ever exist in Antarctica? The data revealed something extraordinary. These forests had thrived when Antarctica was positioned much closer to the equator, before the slow drift of plate tectonics carried it to its current polar position. But that wasn't the shocking part. The shocking part was how quickly the transition had happened. Leaf fossils showed intricate detail down to the cellular level. Ferns with fronds the size of dinner tables. Flowering plants that belonged in rainforests. The ice had created a time capsule preserving an entire ecosystem in perfect detail for millions of years. But some of these specimens were found in layers that suggested rapid burial, not gradual accumulation over thousands of years, but catastrophic events that had buried entire forests almost instantly. The evidence pointed to climate shifts that happened far more quickly than current models predicted. Pollen samples revealed seasonal patterns painting a picture of Antarctica's ancient climate: warm summers, mild winters, rainfall patterns supporting lush vegetation across the entire continent. This wasn't the gradual transition from temperate to frozen that scientists had assumed. The data showed periods of dramatic change that transformed the landscape in what amounted to geological moments. Sediment cores revealed Antarctica's movement during different geological periods. When these forests were growing, the continent wasn't just warmer, it was positioned in completely different latitudes. Continental drift had carried this landmass from tropical regions to its current polar position over millions of years. But here's what really disturbed researchers. Some preserved landscapes showed evidence of rapid climate oscillations. Layers of tropical vegetation followed immediately by evidence of glaciation, then back to temperate forests. The continent had experienced climate swings that made current global warming concerns look gradual by comparison. Ancient riverbeds contained sediments telling stories of massive flooding events, not the kind from heavy rains, but continental-scale deluges that had reshaped entire landscapes. The evidence suggested Antarctica had experienced periods where ice sheets melted completely, creating inland seas and river systems that dwarfed anything on the modern continent. Preserved in the ice were also plant specimens that showed genetic connections to flora found in South America, Africa, and Australia, evidence of when these continents were connected as the supercontinent Gondwana. The time capsule effect had created a museum of Earth's history spanning millions of years. Each layer revealed a different chapter, from tropical paradise to frozen wasteland and everything in between. What made these findings even more significant was their implication for understanding rapid climate change. The preserved evidence showed Earth's climate system was capable of dramatic shifts that happened in time frames measured in decades, not millennia. Antarctica's hidden history was a warning about how quickly our planet could transform. The ticking clock. These discoveries aren't just fascinating glimpses into Antarctica's past. They're fundamentally changing how we understand our planet's future. And it's not a comfortable picture. The climate models scientists used to predict global warming were built on assumptions about how ice sheets behave, gradual melting over centuries, predictable responses to temperature increases, stable timelines we could plan around. But the evidence from beneath those collapsed ice walls shows something terrifying. These massive frozen barriers can disappear far more quickly than anyone predicted. We're not talking about gradual melting over centuries. We're talking about catastrophic collapse events that can happen in years or even months. The Larsen sea collapse was just the beginning.
Larsen B in 2002, it can have a dramatic effect on the stability of the entire structure.
The same conditions that caused that trillion-ton iceberg to break away are now affecting ice shelves across Antarctica. The Thwaites Glacier is showing the same stress fractures that preceded Larsen C's collapse. And Thwaites alone contains enough ice to raise global sea levels by over 2 feet. But it gets worse. Thwaites acts like a cork in a bottle, holding back a much larger ice sheet behind it. If Thwaites goes, it could trigger a domino effect that would release ice containing enough water to raise sea levels by over 10 feet. 10 feet. That would reshape every coastline on Earth. Entire cities would disappear underwater. Miami, New Orleans, Amsterdam, Bangkok, Mumbai, gone. And the newly exposed landscapes are revealing exactly how this process unfolds. Warm ocean water is flooding into caverns beneath the ice, melting glaciers from below at rates that make surface melting look insignificant. The ancient riverbeds and carved valleys show this has happened before, and when it does, the changes are rapid and irreversible. But the discoveries also offer a strange kind of hope. The thriving ecosystems found in those pitch-black depths prove that life can adapt to conditions far more extreme than we imagined. As our planet changes, these findings expand our understanding of where and how life might survive. The race to document these discoveries has become urgent. Every month brings new ice shelf collapses, exposing more hidden landscapes that begin changing immediately once they're flooded with warm water. Scientists estimate they have maybe a decade to fully explore and catalog these environments before they're transformed beyond recognition. The secrets emerging from beneath Antarctica's ice are forcing us to confront an uncomfortable truth. Our planet's climate system is far more dynamic and unpredictable than we realized. The ice walls that collapsed weren't just barriers protecting ancient landscapes. They were barriers protecting us from understanding how quickly our world can change. What comes next? The 1,100-foot ice wall that collapsed in 2017 wasn't an ending. It was an opening, a gateway to understanding that Antarctica isn't the dead, frozen continent we'd imagined, but a complex world hiding secrets about life's resilience, Earth's violent past, and our uncertain future. More ice walls are fracturing, more barriers are failing, more hidden landscapes are about to be exposed. As Antarctica continues to unveil itself, we're racing against time to document what emerges before it transforms forever. What other secrets are waiting beneath the remaining ice? What ancient ecosystems might still be thriving in darkness, unknown and undiscovered? What evidence of rapid climate shifts might be sealed away, ready to rewrite our understanding of how quickly our world can change? And perhaps most urgently, how much time do we have before the next major collapse, before another 1 trillion tons of ice breaks free and reveals something even more profound or more terrifying than what we've already found? The hidden world beneath the ice is already challenging everything we thought we knew. What happens when more of it is revealed might change not just how we understand our planet's past, but how we prepare for its future. What do you think is still hidden beneath Antarctica's ice? Could there be ecosystems even more complex than what we've found? Evidence of climate changes that happened even faster? Share your thoughts in the comments below. And don't forget to subscribe for more discoveries that challenge everything we thought we understood about our world.